Nearly 50 years ago, a radio telescope caught a 72-second signal so strong and so clean that astronomers still can't explain it. In 2025, Avi Loeb revealed something no one expected. The object now passing through our solar system, 3I Atlas, was sitting almost exactly in the direction that signal came from in 1977. And statistically, there's a 99% chance that overlap isn't random. For nearly half a century, you were told that no one knew where the most famous radio burst in CD history came from. It lasted just 72 seconds. It hit the exact frequency scientists expected an intelligent beacon to use, and then it vanished forever. No repeats, no echoes, no explanation. Tonight, you're going to hear the simplest and most unsettling update ever given about that signal. In early 2025, Harvard astrophysicist Avi Loeb asked a question no one had asked seriously before. Where was 3I Atlas during the night of the WOW signal? Not where it is today, not where it was last year, where it was on August 15th, 1977. The exact night that 72-second whisper arrived. Most astronomers assumed the answer would be meaningless, but Loeb ran the numbers anyway, and that's where the story changed. When you rewind the hyperbolic path of 3I Atlas 48 years into the past, it lands in almost the exact same direction of sky that Big Ear was listening to that night. The same narrow window in Sagittarius where the WOW signal originated, not vaguely nearby, not somewhere in the area, within a small handful of degrees. Loeb calculated the odds of that being random. Not impossible, but about 0.6%. In other words, there is a 99.4% chance that the overlap isn't coincidence at all. That is why the title of this video says what it says, because by the numbers, there is a very real possibility, not fringe, not science fiction, not internet hype, that 3I Atlas emitted the WOW signal in 1977, long before any telescope on Earth knew this object even existed. And when you look at what 3I Atlas is doing right now, the story gets stranger. You're watching an interstellar body that is several kilometers across, far larger than any interstellar visitor we've seen, shedding gas like a comet, but behaving nothing like one. Instead of a tail streaming behind it, its brightest material collects in front of it, pointing toward the sun like a headlight. Its chemistry is reversed from normal comets, dominated by carbon dioxide instead of water. It's emitting nickel without the iron that should always accompany it, a pattern closer to industrial refining than natural rock, and its trajectory through our solar system lines up with Mars, Venus, and Jupiter in one carefully timed sequence, as if it were gliding past all three worlds on purpose. All of this is strange enough on its own, but all of it hits differently once you know one thing. This object may have spoken once already. If an interstellar body really emitted a powerful signal from 600 astronomical units away, strong enough for a radio telescope in Ohio to catch it in a single sweep, then you're not just watching a comet anymore. You're watching a traveler whose presence was announced before it ever arrived. And that is why you clicked on this video. Because once someone like Avi Loeb says 99% chance, you want to know why. You want to see the evidence. You want to walk through the physics, the chemistry, the timing, the orbit, the mass, every piece of this puzzle, and decide for yourself whether the WOW signal was a cosmic accident or a deliberate moment of contact from a visitor now passing through the inner solar system. So tonight, you'll follow this story from that 72-second whisper to the silent arc 3-eye atlas we'll make behind the sun. You'll see how each piece of data stacks together, and you'll let your mind wander gently into the possibility that our first interstellar message may not have been received by accident. You'll explore it calmly, slowly, without fear, the way people your age have always explored the night sky, with curiosity, with patience, and with the comfort of knowing you're safe while the universe carries on its quiet conversations. For almost everyone who has heard the story of the wow signal, it arrives as a fragment, a strange spike on a printout, a scientist's astonished red circle, and a mystery left hanging for nearly half a century. But when you start from the beginning, grounding yourself in what a radio telescope actually hears, the strangeness becomes clearer, cleaner, and much less like science fiction. Tonight, you walk through it slowly, because understanding why someone like Avi Loeb says 99% chance requires you to understand first why that 72-second whisper was never normal in the first place. Big Ear, the telescope that caught the signal, did not scan the sky the way your eyes do. It did not swivel. It did not point at targets. It simply sat still, fixed to the ground, and let the rotation of the Earth sweep the sky across its two giant feed horns. Everything drifted past it at the same steady pace. In radio astronomy, that is perfect. The sky moves for you. Big Ear chopped up that drifting sky into thin slices, each tied to a specific frequency band. Most of the time, those bands were full of noise. You hear the same thing if you scroll across radio stations in a car. Static, hum, bursts of interference from electronics, the faint hiss of our own galaxy. Nature produces broad, messy signals. They smear across frequencies. They wobble. They come and go with no clean shape. The wow signal did none of those things. It was narrow. It sat almost perfectly on one frequency. It rose and fell exactly the way a real object would appear and disappear as it passed through the telescope's beam. It did not smear. It did not spill energy into neighboring bands. It came through like a pinprick of light through a fogged window. And then it was gone. To understand why that matters, you only need to know one number: 1420 megahertz. That is the frequency at which neutral hydrogen emits microwave radiation. Hydrogen is the most common element in the universe. From the beginning of CD, scientists agreed that if any civilization wanted to send out a beacon meant to be recognized by anyone else, this would be the obvious channel. The cosmic waterhole, they called it. A natural meeting place. A frequency where nature is quiet, but the meaning is loud. So when Big Ear caught a narrowband burst, clean, centered on the hydrogen line, strong enough to tower above background noise, the reaction was immediate. It looked like an artificial signal. It behaved like an artificial signal. It used the frequency that artificial signals were expected to use. And yet, it was only seen once, never repeated, never found again, despite years of follow-up observations aimed at the exact same coordinates. Non-repeating signals are a problem. Pulsars repeat. Magnetars repeat. Stars flicker. Quasars flare. Black holes howl in radio static. Nature gives you patterns. It does not give you a single perfect tone and then silence for 48 years. If the wow signal had been natural, The simplest explanation would have been that Big Ear caught the edge of a repeating source. But every attempt to find that source again came up empty. For decades, astronomers filed the WOW signal under unexplained, not dismissed, just unsolved. And that would have been the end of the story, unless someone asked where every object in that direction of the sky actually was in 1977. That question, surprisingly, was never taken seriously until Avi Loeb asked it. Loeb's idea was simple. If the WOW signal came from a point on the sky, and if an interstellar object is now traveling through our solar system, why not calculate where that object was at the time of the signal? Interstellar objects do not orbit the sun the way comets do. Their paths are open. They come in, swing around, and leave forever. That means you can run the math backward. You can rewind their motion through space like a film reel. If 3I Atlas is moving on a hyperbolic trajectory today, it must have come from somewhere. And 48 years earlier, it must have been somewhere specific along that line. When Loeb performed that rewind, the result was not subtle. In August of 1977, 3I Atlas was roughly 600 astronomical units from Earth, almost directly in the thin region of sky where the WOW signal originated. Not roughly nearby, not in the same quadrant, almost exactly in line. To appreciate that distance, imagine Pluto at 40 astronomical units. Now imagine traveling 15 times farther. You are deep in the outer darkness where sunlight is nothing more than a cold glimmer. If you kept going, another few thousand astronomical units would bring you into the Oort cloud, where comets sleep for millions of years. 600 astronomical units sits in between, far, silent, and empty. A place where nothing should be able to shout, and yet someone, or something, may have done exactly that. The next question is probability. If interstellar objects were constantly pouring through the solar system, the coincidence might not be meaningful. But interstellar objects are rare. Before Oumuamua in 2017, humanity had never seen one. 3I Atlas is only the third such object ever identified, and the sky is enormous. 4 pi steradians enormous. The WOW signal's uncertainty region, the area of sky where the signal could have come from, is tiny by comparison. When Loeb calculated how likely it was for any interstellar object to fall inside that region purely by chance, the answer came out to roughly 1 in 160. That is about 0.6%. Flip it around and you get the headline. About a 99.4% chance the alignment is not random. But probability is only part of the story. The signal's strength matters too. Based on the brightness recorded by Big Ear, the source would have emitted somewhere between 0.5 gigawatt and 2 gigawatts of power at the distance of 600 astronomical units. That is not a campfire. That is the output of a power plant. In human terms, it is the scale of a working reactor. Nature can produce enormous energy, of course, but when it does, it usually produces it broadly, not in a narrow spike on a quiet frequency band associated with intelligent communication. So you start stacking facts. A narrowband burst, tuned to the hydrogen line, non-repeating, clean, short, exactly shaped like a source drifting through a fixed beam, strong, and originating from the same region of sky where 3I Atlas was sitting at the time, with a probability of random alignment well under 1%. The pieces begin to form a picture. Not a conclusion, but a picture. This is where Loeb's caution becomes important. He does not claim certainty. He does not declare that 3i Atlas is a transmitter or a craft. What he says is simpler, sharper, and harder to ignore. When a single event aligns this well with the path of an interstellar object, dismissing it as coincidence is not scientific skepticism. It is avoidance. You can test the meaning of that for yourself. If a doctor told you there was a 99% chance of inflammation in your heart, you would not shrug and call it coincidence. You would ask questions. You would want explanations. You would want data. A probability that high forces you to pay attention, even if the subject feels uncomfortable. That is the purpose of this part of the journey. Not to insist on an answer, but to establish why the question is worth asking. The wow signal has always been mysterious. Tonight, you see it in a different light. Not as an isolated burst in the dark, but as something that may connect directly to the object drifting through the solar system right now. If you imagine that 600 AU distance again, picture the silence out there. Picture something sitting in that cold, watching our star, our planets, and the faint line of radio telescopes turning with the Earth. If a burst really came from that distance, and if that burst passed directly through Big Ear's field of view, then you are not dealing with an accident of timing. You are dealing with something that happened once, precisely when a specific object occupied that slice of sky, and never again. Understanding that possibility does not require fear. It simply requires clarity. The numbers are clear. The signal characteristics are clear. The rarity of interstellar objects is clear. And the alignment, running backward through time, is clearer than anything else in the story. When you look at it this way, the title of this video stops sounding dramatic. It becomes a straightforward description of the scenario you are exploring. If 3i Atlas really emitted a signal in 1977, then the WOW event was not just a mystery. It was the first chapter in a long, slow approach that only now is reaching the inner solar system. And the moment you accept that possibility, something else becomes important. The path this object took to reach us, where it came from, how it entered our system, and why its trajectory looks the way it does. If 3i Atlas may have emitted that signal in 1977, then its path into our solar system is not just a trajectory, it's a story. And that story, written in gravity and timing, is our next chapter. When you step back from the 1977 signal and look at the object now moving through our solar system, a different kind of mystery begins to surface. One written not in radio waves, but in motion. If the WOW signal was a greeting, then the path 3i Atlas has taken since that night feels less like a random drift and more like a deliberate visit. You are about to trace that path the way you would trace a route across a map. And as you follow it, point by point, you may notice something that astronomers rarely admit out loud. Sometimes, the sky looks a little too organized. Begin with a reminder of what you learned in the last chapter. If an object 600 astronomical units away emitted a signal strong enough to reach Earth, and if that object is now inside the orbit of Mars, then its journey is not a blur. It is a long, calculated arc across decades of space. That arc is the spine of the story. And the first thing you notice when you study it closely is that it refuses to behave like a conventional comet. Anomaly 1. Retrograde, but ecliptic aligned. Retrograde simply means moving the opposite direction from the planets. Everything in the solar system, from Mercury to Neptune, moves around the Sun in the same general direction. Comets from the Oort cloud come in from every angle, but they almost always tilt sharply above or below the plane of the planets. They dive in steeply, or rise in steep loops, or fall sideways. They almost never slip in along the same thin, flat sheet where the planets orbit. 3I Atlas does. Its path is retrograde, the opposite direction of everything else, but its tilt from the ecliptic plane is only a few degrees. That is extremely unlikely. If you imagine the solar system as a giant dinner plate, most comets approach from far above or far below, flying in like insects from the ceiling or the floor. 3I Atlas, however, chooses to skim almost exactly along the rim of that plate, but heading the wrong way. The odds of that happening by chance are very small. You can picture it this way. If you fired a bullet from the far end of a field without aiming, the chance that it would pass within a hair's width of a narrow tabletop in the distance is tiny. And yet that is what 3I Atlas does. It does not wander through the solar system. It glides through the same plane our worlds share. If you begin with the idea that the wow signal might have been intentional, then this first anomaly feels like a traveler choosing to arrive along a familiar highway instead of crashing in from above. Anomaly 2. Visits to Mars, Venus, and Jupiter. Once you notice how neatly 3I Atlas aligns with the ecliptic, the next pattern becomes obvious. As it sweeps inward, it passes near 3 of the most important worlds in our planetary system. Not just physically important, but scientifically interesting. Places any mission, natural or artificial, might want to study. It brushes near the orbit of Mars first. Mars, with its history of water, its frozen lakes, its thin but reactive atmosphere, and its decades of robotic exploration. A world that humans have stared at for generations, wondering how life could arise and how it could end. When 3I Atlas slides past Mars, it does so at a distance that makes observation possible, but collision impossible, as if it wants a look, but not an impact. Then it dips toward the orbit of Venus. Venus is Earth's twin gone wrong, a planet of volcanoes, crushing pressure, and unknown chemistry inside its yellow clouds. For astrobiology, Venus is a puzzle box. If you wanted to understand the difference between a habitable world and a runaway greenhouse furnace, you would compare Earth to Venus. And here, again, 3I Atlas takes a path that swings close enough to gather perspective without getting pulled in. Finally, it bends outward toward the orbit of Jupiter. Jupiter is the king of the system, a massive world whose gravity shapes everything around it. It is also the gateway to Europa, Ganymede, and Callisto, 3 icy worlds with subsurface oceans. Planetary scientists treat these moons the way oceanographers treat deep-sea vents, places where life could exist without sunlight. And in a single journey, 3I Atlas crosses near all 3 of these worlds' parent planet. Most comets never do anything like this. They swing in, swoop around the sun, and leave. Their paths are chaotic. But when you plot the motion of 3I Atlas on a map, it does not look chaotic. It looks like a survey route: Mars, Venus, Jupiter, in that order. If you saw an aircraft skim past 3 major cities on Earth in one flight path, you would not call it a coincidence. You would call it an itinerary. That is why Loeb once remarked, If you saw an object skim past all the major cities on Earth in one trip, you wouldn't call it an accident. You'd call it a route. Anomaly 3. The hidden perihelion. On October 29, 2025, 3I Atlas reaches perihelion, the closest point to the Sun. Every comet accelerates dramatically at this moment, falling deep into the Sun's gravity well, and then slingshotting back out. If you wanted to alter your path in space using as little energy as possible, this is the perfect moment. A maneuver performed at perihelion is amplified by the Sun's pull. Space engineers call this a solar Oberth maneuver, and it is the most efficient way to change direction on an interstellar trajectory. And yet, at the exact moment when such a maneuver would be most effective, the object becomes invisible from Earth. The glare of the Sun overwhelms it completely. For several days, no telescope on this planet can see it. Even spacecraft positioned elsewhere in the solar system struggle to view anything that close to the Sun's radiant curtain. It slips behind the star, like a diver disappearing behind a waterfall. For a comet, that is normal. For a traveler, it is ideal. You cannot help but notice that this moment of invisibility arrives precisely when the object could change its path most dramatically. If 3I Atlas were to adjust its direction here, almost no one would see it. Only when it emerges from the other side will the truth be visible. Whether it continues on as expected or takes a new direction entirely. This is one of the rarest alignments in the entire narrative. The perfect moment to hide the perfect maneuver. Anomaly 4. The forward-facing dust cocoon. When you imagine a comet, you imagine a tail blowing backward, away from the Sun. Solar radiation pushes dust and gas outward. The dust forms a pale streamer behind the nucleus. The physics is clear. The tail should always trail behind the comet's motion. 3I Atlas does the opposite. Instead of trailing behind, its densest dust collects in front of it, almost like a shield. The bright region is not on the downwind side, but the sunward side. If you picture a vehicle orienting panels or instruments toward the Sun, you get something eerily similar. It is as if one face of the object always stays aligned toward the star, no matter how it rotates. That is very difficult to explain with cold physics alone. This forward-facing glow is not subtle. Astronomers noticed it early. Naturalists suggested unusual chemical outgassing. Engineers, quietly, suggested orientation behavior. No one claims certainty. But the visual effect is unmistakable. The brightest part of 3I Atlas is on the wrong side. Imagine driving through a snowstorm and seeing the snow swirl toward the windshield instead of the rearview mirror. That is how strange this anomaly feels. Anomaly 5. The enormous mass. Finally, you arrive at scale. 3I Atlas is large, possibly several kilometers across. Its mass is estimated at 33 billion tons or more. That is staggering. Oumuamua, the first interstellar visitor detected, was tiny by comparison. Little more than a shard. Borisov, the second, was medium-sized, but still modest. The third visitor humans ever detect should not, by chance, be a giant. If you roll 3 dice, and the first 2 come up small, the third should not come up as a perfect, oversized outlier. The odds of detecting an interstellar object of this size so early in humanity's observational history are low. And yet, here it is, heavy enough to survive long journeys intact, large enough to carry mysteries across the gulf between stars. When you place these 5 anomalies together, you get a picture that is hard to ignore. The retrograde but ecliptic-aligned entry, the sequence through Mars, Venus, and Jupiter, the hidden perihelion, the forward-facing dust cocoon, the improbable mass. Each one is strange by itself, but placed in order, they begin to look like markers on a path, each leading naturally to the next. You can trace them with your finger the way you would trace a route on a star chart. This is where it entered the plane of the planets. This is where it skimmed past Mars. This is where it bent toward Venus. This is where it headed toward Jupiter. This is where it will hide behind the sun. Each step feels connected, not scattered. Each turn feels intentional, not chaotic. And this is where a simple question rises. At what point does coincidence begin to look like choreography? You are not asked to believe anything extraordinary. You are simply looking at the facts as they are. If the wow signal was emitted from the direction where 3I Atlas sat in 1977, and if its path since then follows a sequence that mimics a survey of our most interesting worlds, you cannot ignore the possibility that this object has been on a mission of some kind. Not a story of fear, just a story of motion that feels too tidy for randomness. This part of the journey is meant to leave you with a clear mental map. You can picture the object now, gliding against the flow of the planets, slipping past the worlds we ourselves study with so much passion, disappearing into the sun's glare, and carrying 33 billion tons of material along a narrow, unlikely course. It is not just passing through space. It is passing through the most meaningful regions of our system. If you saw an aircraft trace this exact path above Earth, touching the airspace of every major region of interest, you would not call it wandering. You would say it had a destination, even if you did not know what it was. And that is all this chapter asks you to notice. A pattern of motion that feels less like drifting and more like a plan. A path that looks planned is one thing, but a traveler that looks engineered is another. To see that, we have to look at what 3I Atlas is made of. When you look at a comet, you expect something simple: ice, dust, a faint glow of water vapor turning into gas as sunlight warms it. For centuries, that was the model. Comets are frozen leftovers from the dawn of the solar system. Their chemistry is primitive, familiar, and predictable. But the closer you look at 3I Atlas, the farther you drift from that picture. If its path looks planned, its interior looks engineered. And the deeper you go into the evidence, the harder it becomes to see this object as an ordinary chunk of rock and ice drifting between the stars. Begin with the atmosphere it creates around itself. When sunlight heats the surface of a comet, water usually dominates the outgassing. You see water vapor, hydrogen, oxygen fragments, carbon monoxide, and a minority contribution from carbon dioxide. That mix is well understood. Water ice is abundant in comets. CO2 is a supporting player. 3I Atlas reverses that pattern almost completely. Observations show that roughly 95% of its outgassed material is carbon dioxide. Only about 5% is water. That is astonishing. It is as if someone took the standard recipe for a comet and inverted it. Scientists tried to explain the imbalance by pointing to cosmic rays, high-energy particles that can strip water from the surface over millions of years, leaving CO2 behind. But that mechanism only operates on the outermost layers. Once the object warms and begins to shed deeper material, the ratio should return to something more typical. It does not. As weeks pass and fresh layers sublimate, the CO2 dominance stays. It holds its 95% lead as if the interior matches the exterior exactly. Not layered, not varied, consistent. That kind of uniformity is difficult to reconcile with natural formation because comets form from mixed materials. They are dirty snowballs, not single-ingredient sculptures. And this is only the start. Look next at the element nickel. When astronomers point spectrographs at 3I Atlas, they see emission lines from nickel, but almost none from iron. In nature, this should not happen. Nickel and iron are born together inside supernovae. They are siblings. They condense out of hot stellar debris in locked ratios. If you find nickel, you find iron. If you find iron, you find nickel. Unless something has separated them. On Earth, nickel without iron means one thing: industrial refinement. Humans separate nickel from iron to build alloys, catalysts, and components. The process is energy intensive. It involves chemistry that happens inside factories, not inside comets. So when astronomers detected nickel lines from 3I Atlas, but found iron curiously missing, the reaction was not panic. It was confusion. There is no obvious natural mechanism to do this on a large scale. Comets cannot run metallurgical plants inside their frozen hearts. But the anomalies continue. Consider the molecule nickel carbonyl. On Earth, this compound appears in only one major place: the refining of nickel. It is volatile, meaning it vaporizes easily. It is used to purify metal, allowing nickel to be transported and decomposed elsewhere. It also happens to produce spectral signatures that look suspiciously similar to the ones 3I Atlas gives off. No one is claiming certainty, but the possibility is strange enough that it becomes difficult to ignore. If nickel carbonyl truly exists around this object, it is either a wildly unlikely coincidence or it is a leftover trace of a technological process, the kind of chemistry you would expect from engineered metal, not frozen stone. Now return to something you can see with your eyes: the green glow around 3I Atlas. Green comae are not unheard of. Some comets glow green due to cyanogen and diatomic carbon breaking apart in sunlight. Natural explanations exist, but with 3I Atlas, the glow comes with a twist. Cyanide compounds increase as it approaches the sun, rising faster than expected. Again, nothing is impossible here. But when the pattern of CO2 dominance, nickel without iron, and volatile metal-bearing molecules stacks together, the green coma shifts tone. It is no longer just a color. It is a clue. Each of these anomalies, by itself, could be dismissed. Together, they form a pattern that feels more like byproduct than geology. If you want to emit a powerful radio signal from deep space, you need infrastructure. You need a platform. You need materials that can survive radiation, hold structure, channel energy, and radiate power in narrowband frequencies. You need engineered elements humming beneath the surface. Ask yourself what the scars of such a system would look like after millions of years between stars. Not polished panels or clean lines, but traces, odd chemistry, refined metals, volatile compounds, residues that do not belong in the wild. You may not see the structure directly, but you see what it sheds. And when you look at 3I Atlas through that frame, its chemical mix begins to resemble leftovers, not the primary machine, but the footprints of it. You do not have to assume anything dramatic. You only have to notice what stands out. Carbon dioxide where water should be. Nickel without iron. Molecular species that belong in metal processing. Cyanogen intensifying with heat. A recipe that does not match the natural cookbook. This part of the journey is not meant to convince you that 3i Atlas is artificial. It is meant to show you why the hypothesis is no longer fringe. You have already followed the path it takes through space. Now you follow the materials it leaves behind. In both cases, the pattern is the same. Too ordered, too inverted, too consistent to dismiss casually. And this brings you back to the signal. If an interstellar body could emit a burst powerful enough to sweep across a radio telescope on Earth, it would need mass, stability, power, and structure. It would need a way to store energy, a way to protect volatile compounds, a way to manage heat and radiation. All of that requires specific materials, and materials leave residue. This is where the detective work begins to feel less like speculation and more like pattern recognition. You are not being asked to make a leap. You are being asked to observe, to notice that the chemistry looks as though it belonged to something that did work, not something that simply sat frozen for 5 billion years. That the emissions look like the signature of processed metal, not raw ore. That the persistent CO2 dominance resembles a controlled composition, not an evolutionary accident. It is here that Loeb offers another quiet reminder. When the chemistry looks more like a laboratory than a comet, we have to ask whether nature is really the only chemist at work. You are not expected to draw conclusions tonight. You are simply being given a framework, a way to interpret what telescopes are telling you. And the framework is this. If 3i Atlas once emitted a signal, this is the kind of machine you would expect behind it. Something large, structured, and chemically odd. Something that releases volatile compounds for reasons we do not yet understand. Something whose composition suggests use, not dormancy. With each new clue, the idea grows less abstract. Retrograde alignment, planetary flybys, hidden perihelion, forward-facing dust, 33 billion tons of mass, and now a chemical signature that drifts away from the natural world and into the engineered one. You are slowly peeling back layers, not to prove anything, but to understand the scale of the unknown. And as the picture sharpens, a new question forms. How suspicious should you be? How far do you go with this line of thought? What is reasonable? And what is imagination? To keep yourself honest and safe, Avi Loeb suggests a scale. When you listen to the chemistry, the path, and the timing of 3i Atlas, the questions begin to pile up. And once the questions reach a certain weight, you need a framework, a way to size the unknown. Avi Loeb proposed one for exactly this purpose, not to frighten anyone, and not to feed speculation, but to give the scientific community a common language for dealing with objects that look natural at first glance, and increasingly suspicious the closer you look. He calls it the Loeb scale. Imagine a simple line marked from 0 to 10. At 0, you place an object that is completely natural, something like Comet 2I Borisov. It behaved exactly as comets should. No anomalies, no surprises. A frozen traveler minding its own business. It is the baseline of cosmic innocence. At 10, you place an object that is confirmed artificial, hostile, and on a direct collision course with Earth. We have never encountered anything like that. We hope we never will. Category 10 is where science fiction becomes survival. Everything else falls somewhere in between. And right now, 3I Atlas sits at level 4. Level 4 means seriously suspicious but unproven. Not a panic category. Not an extraordinary claim. It is the point on the scale where the pattern of anomalies is too consistent to ignore, and the burden shifts to careful observation and strategic caution. A level 4 object is like seeing a long shadow at dusk. You do not run, but you do not pretend the shadow is nothing but a trick of the light. Loeb estimates that the probability 3I Atlas is technological cites around 40%. Far from certainty, but far from trivial. When you hear that number, it helps to translate it into everyday terms. If a doctor told you that you had a 40% chance of a serious cardiac issue, you would not call it just speculation. You would investigate. You would run tests. You would stay alert. A 40% chance is not a prediction. It is a reason to pay attention. That is the spirit behind the scale. Once you see the number that way, another idea begins to gain context: the dark forest. In that metaphor, the universe is a vast forest filled with silent civilizations. Every species knows that making noise can attract unwanted attention. The safest strategy is to stay quiet. Hide your campfire. Avoid drawing notice. In such a place, sending out a beacon, especially a beacon powerful enough to be heard across 600 astronomical units, is not a casual act. It is deliberate. It is bold. It signals one of two things: confidence or predation. If 3I Atlas emitted a signal in 1977, then it broke the silence of the forest. It announced itself in a way that natural comets never do. And objects that announce themselves may not always be announcing friendship. They may simply be announcing presence. This is not a call to fear. It is a call to perspective. A radio whisper that's strong from that far away is a move, not an accident. And in a universe where silence is often safer, a move deserves attention. The concept becomes sharper when you pair it with the size of 3I Atlas. Don't think of it as a single rock. Think of it as a platform. Something large enough to carry smaller probes. Something massive enough to endure interstellar travel. Something that could have begun its mission before it ever entered our solar system. If it truly emitted a signal from 600 astronomical units, then the mission may not have started here. It may have started out there in the dark. That is where the mothership idea enters the discussion. It is not meant to evoke images of sleek crafts or metallic holes. It is meant to describe scale. A traveler, several kilometers across, passing near multiple planets, shedding unusual chemistry, orienting dust in unexpected ways, and aligning with a famous radio mystery, is a legitimate candidate for a mother platform, a host from which smaller objects could be deployed. We may never detect those objects directly. They may already have moved past us, or they may never have existed. But the combination of mass, trajectory, and chemistry is enough to place the possibility on the table. And yet, despite the weight of these ideas, this part of the journey is not meant to unsettle you. It is meant to anchor you, to show you how scientists think about risk in a rational way, to demonstrate that acknowledging suspicion is not the same as announcing danger. A level 4 object is not an emergency. It is simply a reason to be methodical. The same way a pilot is methodical when instruments flicker, or a doctor is methodical when symptoms cluster. You are not being asked to imagine the worst. You are being asked to understand the middle ground, the zone where curiosity must be accompanied by caution, where an object is no longer just a curiosity, but a strategic variable, a thing that might merit closer inspection, not because it threatens you, but because ignoring it would be unwise. You are also being reminded that none of this rests on fear. The universe is old. It is quiet. And tonight, nothing in it is rushing toward you with harm. You are being invited to watch the sky with calm eyes, to understand the logic without absorbing the dread. This is a story about perspective, not prophecy. That is why Loeb also says, we cannot afford to be arrogant in a universe that might be listening back. Arrogance is assuming we know the answer before we ask the question. Caution is acknowledging that we do not. And tonight, caution simply means staying aware. Understanding what a 40% chance truly implies. Accepting that if an object once emitted a signal, it is not just a point of interest. It is a risk factor that scientists must treat seriously, even as they remind the public that the sky is calm and no immediate danger exists. This chapter is your grounding point. It lets you take a breath and place the mystery in context. You have seen the path. You have seen the chemistry. You have seen the scale. Now you understand the temperature of the discussion, why scientists debate this object, and why they measure its strangeness carefully instead of shrugging it off or exaggerating it. And with that perspective, the next logical step becomes simple. If this really is a suspicious traveler, the most responsible thing to do is get a closer look. And the solar system has already arranged one for us, at Mars. Long before you ever heard the name Three-Eye Atlas, Mars had already been circling the sun for billions of years, silent, cold, and patient. Tonight, it becomes something else entirely, a vantage point, a witness, a world whose robotic scouts just happen to be in the right place at the right time as an interstellar traveler drifts past. You can picture it now. A small red planet hanging in the darkness, turning slowly. Above it, 3 spacecraft glide along their orbital paths, their instruments quiet, their cameras pointed outward, and in the distance, a faint, dark blur is approaching, slow, steady, and impossibly old. For the first time in human history, multiple eyes in space are about to look directly at an object that might once have spoken to us from the outer reaches of the solar system. The geometry of this encounter is almost poetic. Three-Eye Atlas will never pass close to Earth. Its path doesn't give us that luxury, but it will slide within about 29 million kilometers of Mars. That distance is far enough to be safe, yet close enough for high-resolution imaging. You cannot touch something from that far away, but you can study its glow, profile its shape, examine its dust, and capture the way it scatters sunlight. From this vantage point, every spacecraft around Mars turns in unison. Mars Reconnaissance Orbiter swings its high-rise camera toward the faint motion against the stars. Mars Express rotates its high-gain antenna and scans in optical and infrared. Even the ExoMars Trace Gas Orbiter angles its sensors at the same target. You can imagine these machines, quiet, solar-powered, patient, staring across tens of millions of kilometers at something drifting inward like a slow piece of night. 3 orbiters, one planet, one suspected emitter. At 29 million kilometers, you will not see metal plating or carved structures. But you can see the difference between a lumpy, natural object and something that holds its form too cleanly. The range allows you to estimate size. Is it closer to half a kilometer, or is it more like 5? You can measure the roundness, the elongation, the tumbling behavior. Natural comets tumble chaotically. Artificial structures do not. They maintain attitude, and you can study the pattern of its dust. A natural object emits jets of gas and dust that radiate outward like the spokes of a wheel. They align with heat sources, fractures, and topographical variations. But if 3i Atlas shows jets that all lean in one direction, or dust whose brightest region sits in front rather than behind, something we've already begun to observe, then Mars may give us the sharpest confirmation yet of its strange behavior. The way dust behaves near Mars tells you something simple but profound. Is this object rotating freely, or is it orienting itself purposefully? Then comes the spectral check. Mars offers an angle we don't have on Earth. With its orbiters, you can compare the chemical signature seen from Mars with the signatures captured by Earth-based observatories, JWST, and other instruments. If the chemistry changes as 3i Atlas draws closer, the change may reveal fresh material from deeper layers. Layers that tell you whether its composition is stable, stratified, or engineered. Will the CO2 ratio change? Will nickel lines grow stronger or weaker? Will iron lines finally appear? Will cyanide spike as sunlight intensifies? Spectra are the fingerprints of matter. If the fingerprints change, you learn what the object was hiding beneath its outer shell. The emotion behind this moment is quiet, almost spiritual. You stand with an entire species waiting for a set of images that may tell you whether the first interstellar visitor ever linked to a possible radio signal looks like a natural wanderer, or something that once served a purpose. And the extraordinary part is that nothing about this moment is violent. Nothing is rushing toward you. Nothing threatens you. It is simply the universe offering a glimpse. You are watching an encounter framed not by fear, but by curiosity. Picture the scene now. The orbiters are gliding above Mars against a red horizon tinged by faint sunlight. The planet rotates slowly beneath them. The stars above are pinpoints of ice, and out there, 3i Atlas slides across the field of view as a gray, uneven shadow. You know it is traveling at tens of thousands of miles per hour, yet it appears motionless, suspended in the cosmic stillness. Only the readouts on the instrument panels reveal the truth, that this is a rare alignment, the kind that happens once in many lifetimes. What we hope to see is simple and specific. If the object is entirely natural, it should look rugged, asymmetrical, like a potato-shaped fragment of primordial rock. Its outgassing should be messy. Its dust plume should trail behind. Its color and reflectivity should match what we know from other long-period comets. If the object is not natural, it may still look irregular, but irregular in a different way. It may hold a shape with surprising consistency. It may produce jets from surprising directions. It may reveal edges or gradients that hint at internal structure. You do not expect a perfect silhouette. You expect hints, details that lean one way or another. A scientist once put it simply: if you suspect a ship, you don't just listen to its radio, you try to see its hull. The flyby at Mars gives you your first chance to see that hull, however faintly. There is also something cinematic in the way this encounter unfolds. You can almost feel the tension, but it is gentle. This is not a chase. It is not an alarm. It is the slow turn of a camera toward the unknown. You are not clenching. You are leaning forward. You are not holding your breath. You are settling into a moment where knowledge inches closer to clarity. Because if the wow signal was truly a deliberate whisper, then the object that produced it is now passing as close to human instruments as it may ever come. Mars becomes the balcony seat from which you watch the traveler approach center stage. And yet, even here, a limitation remains. Even with 3 orbiters, even with telescopes across multiple worlds focused on one point, the most dramatic moment still lies ahead. Mars gives us a preview, a silhouette, a taste of the truth. But the definitive chapter waits in a place where our view collapses into blindness. Shortly after the Mars flyby, 3I Atlas continues inward toward the Sun, where it will enter the deepest part of the star's gravitational well. That is where a natural comet burns brightest, and where an engineered traveler could alter its course most effectively. It is the chapter where trajectories can change, where intentions can be revealed. And tragically, it is also the moment when the object becomes invisible from Earth. The Mars encounter is the checkpoint. It is the brief window where nature gives us a chance to stare at the suspected emitter before it disappears into light. But cameras alone cannot tell us where a traveler is truly headed. For that, we must watch what it does in the deepest part of the Sun's gravity well. For weeks, you've watched 3I Atlas drift inward like a slow, ancient arrow. It crossed the orbit of Mars, brushed past the red planet's robotic eyes, and kept falling toward the Sun with the inevitability of a stone dropped into a well. And now, as it approaches perihelion, the closest point in its path, everything you know about this object gathers into one question. What will it do when no one can see it? Perihelion is where comets reveal their true nature. Heat rises. Radiation becomes brutal. Dust and gas erupt from fractures. Velocities spike to their maximum. But for 3I Atlas, perihelion is more than a moment of physics. It is a moment of invisibility. From Earth's perspective, the object sinks into the Sun's glare and disappears. You cannot track it with telescopes. You cannot measure its jets. You cannot resolve its path. It becomes a silhouette swallowed by light, a traveler stepping into a blinding doorway. For several days, 3I Atlas is simply gone. And whatever it chooses to do during those hidden hours determines everything that comes next. This disappearance is not unusual. Many comets vanish in the brightness of perihelion. But in this story, where an object may have sent a narrowband signal in 1977, this blind spot becomes meaningful. Because if an engineered traveler wanted to adjust its path without being observed, this is the perfect place to do it. In the language of orbital mechanics, perihelion is the Oberth point. A burn, any burn, done deep inside a gravitational well produces far more change in trajectory than the same burn done far away. It's like pushing a swing when it's at its fastest arc. A small nudge can redirect the entire motion. Engineers know this. Spacecraft designers use this. If a machine wanted to reshape its route through the solar system, perihelion would be the most efficient place to do it. And so, At the very moment when 3i Atlas becomes invisible, you reach the branching point. Everything that follows depends on what happens inside that doorway of light. Scenario A is the simplest. No burn at all. In this case, 3i Atlas emerges from behind the sun, exactly where classical astronomy predicts. Its post-sun trajectory lines up with gravitational models. No sudden drift, no unexpected tilt, no deviation toward any world. If this scenario plays out, the mystery remains. But the weight of artificial intent lightens. The object would behave like an extremely strange comet, but a comet nonetheless. Scenario B is more subtle and more intriguing. A slight burn, a gentle push. Not dramatic enough to shock orbital models, but enough to shift its path by a fraction of a degree. A small adjustment, noticeable only to those who have been watching closely. If this happens, the new path may guide it toward Jupiter or toward the icy worlds of Europa and Ganymede. These are worlds with subsurface oceans, prime targets in any scientific or reconnaissance mission. A traveler performing a deep survey might choose exactly such worlds for a second pass. And if you're thinking of 1977, of that quiet, powerful radio signal sent when 3i Atlas was far beyond Pluto, you might notice something. A subtle burn would fit the logic of a mission. Listen from a distance, wait for a response, then adjust your course to examine the inner planets more closely. Scenario C is the boldest. A strong burn, a pronounced alteration, a decision large enough that astronomers cannot shrug it off as randomness. In this scenario, 3i Atlas arcs inward toward Earth's orbital lane, not as a collision threat, simply as a flyby, an opportunity to gather data, to measure a planet rich in life, atmosphere, and radio noise. A close pass, months after perihelion, would be the natural step 3 in a long, deliberate sequence that began in 1977 with a single, narrowband whisper. None of these scenarios predict danger. They predict intention. And intention can be studied. That's the emotional tone of this moment. Not fear, but a calm tension, the feeling of standing at the threshold of a chapter you cannot yet read. You know something meaningful may occur behind the curtain of sunlight. You know you will not know immediately. You know the final shape of its path is the key to understanding whether 3i Atlas is drifting or navigating. This is where the wow signal returns. If that signal was Act 1, a whisper sent from 600 astronomical units, then perihelion becomes Act 2. After the whisper comes the move. After the call comes the step forward. If something or someone aboard this object was listening for signs of life, waiting for a clue, collecting noise from our planet, then a course correction near the sun would be the logical next step. Not dramatic, not aggressive, just purposeful. And yet, you are reassured by the scale of space. Even the boldest scenario gives you months of time. Even the closest flyby remains distant on human terms. Nothing is rushing toward you. Nothing is spiraling into a threat. You are a spectator, not a participant. This is a cosmic investigation, not a crisis. As 3i Atlas rounds the sun, its future diverges into branches, and you will be able to measure which branch it took. Telescopes in Earth orbit, ground-based observatories at dawn, even spacecraft positioned at the right angles, all will contribute to the hunt for its reappearance. There is a serenity in that. The universe hides its secrets briefly, but only briefly. Light returns. trajectories become clear again, and you will know which story you are living. The strongest image of this chapter is simple: a 5-kilometer wanderer slipping behind the sun like a vessel entering a zone where radar cannot reach. It is not a threat, it is a question mark. And for a short time, that question mark glows brighter than anything else in the sky. Avi Loeb once phrased it like this: if this object changes course near the sun, after already aligning with the wow signal, we should treat it as intentional behavior. Not fearful behavior, not hostile behavior, just intentional. And so you wait, not anxiously, but with a kind of cosmic patience. You know that when the object emerges from the sun's glare, the next phase of the story will begin. A trajectory is not just a path, it is a signature. While the object writes its next line behind the sun, we are left with something uniquely human to study. Not the comet, but ourselves. The moment a scientist utters the phrase 99% chance, the internet hears something entirely different. The nuance disappears. The caution evaporates. And the quiet space between maybe and certainty becomes a playground for chaos. As 3i Atlas slips behind the sun, hidden from every telescope on Earth, that quiet gap fills instantly, not with data, but with noise. You've seen this pattern before. The object slows down by 2%. Someone calls it propulsion, a faint flicker in a telescope feed. Someone claims it's a 17-minute pulse, a missing update from NASA. Suddenly, it's proof of a cover-up. Old conspiracy scripts return. Project Bluebeam, fake invasions, doomsday predictions recycled from one anomaly to the next. None of them are new. All of them are loud. This is what happens when the universe hands humanity a 99% maybe. Your brain does not like open doors. It does not like unanswered questions. It does not like ambiguity. When something sits in the space between probably and proven, we instinctively reach for stories to fill the gap. Some people reach for fear. Some reach for mockery. Some reach for nothing at all. In that swirl of interpretations, 3 groups always emerge. The first group is the doomers. For them, 3i Atlas is already a threat. The wow signal is already a hostile ping. The anomalies are already deliberate maneuvers. Their minds connect dots quickly, decisively, sometimes dramatically. A 99% maybe becomes a 100% prophecy. The second group is the dismissers. They laugh. They shrug. They do not want the world to be complicated or strange. If something unsettles the model they're used to, they push it away with sarcasm. To them, 3i Atlas is just a comet, and any mention of signals or anomalies is hype. They prefer certainty, even if it's the certainty of indifference. And then there's the third group, the drifters. They hear the news, raise an eyebrow, and go back to their routines. They forget the story until the next headline appears, and even then, only vaguely. They are not alarmed, not amused, not invested. The cosmos is interesting, but life is busy. Most of humanity quietly lives in this group. These 3 tribes appear every time we encounter uncertainty. They are not wrong or right. They are simply human. But in the middle of all that noise, something quieter exists. A group without a label. A group that steps back from the extremes. A group that listens not for answers, but for understanding. If you are here, listening to this story tonight, you might belong to that quiet middle. You are not required to declare that the object is artificial. You are not required to dismiss anomalies as hype. You are simply allowed to hold the question, to let the uncertainty be a kind of meditation, to notice how your mind reacts when presented with a 99% maybe. You don't need to solve anything. You don't need to choose a side. You can just observe. Because maybe the story of 3I Atlas isn't only about whether it emitted a signal in 1977. Maybe it's about how humans react when the universe offers us something that is almost confirmed, but not quite. A signal that might be real. A traveler that might be artificial. A pattern that might be intentional. And a silence behind the sun that might reveal something when it ends. This chapter softens the entire journey. It removes the adrenaline and replaces it with perspective. You begin to see the narrative not as a threat or a spectacle, but as a mirror, a way to understand your own relationship with uncertainty, a way to practice stillness in a world that is rarely still. You might feel a faint smile at the absurdity of some online theories. You might feel a small warmth at the thought that most people never noticed any of this. You might feel a gentle pride in being part of the group that can hold curiosity without spiraling into fear or mockery. And you might feel something deeper, relief. The relief of not needing to be certain. The relief of knowing that you can be thoughtful without being dramatic. The relief of stepping away from extremes and simply listening. Listening the way you listen to a distant, calming story. One that lets your mind wander without gripping too tightly. A philosopher once said, "Sometimes the most honest position is not I believe or I deny, but I will watch and I will rest." It is a gentle reminder that you do not have to carry the weight of every unanswered question. Tonight, that reminder becomes your anchor. You do not have to interpret the internet noise. You do not have to sort the tribes. You do not have to decide whether 3I Atlas is a comet, a wanderer, a machine, or something in between. You are allowed to sit in the quiet middle. You are allowed to breathe. You are allowed to drift. So tonight, you don't have to solve the mystery of a 72-second signal or an interstellar traveler. You only have to make it safely to sleep. You've traveled far tonight, farther than you realize. You began with a whisper from 1977, a 72-second rise and fall along the hydrogen line. You followed that whisper across decades, all the way to a dark interstellar traveler whose path and chemistry refused to behave like anything familiar. Fact, debate, imagination, each one took a turn holding your attention. And now, at the end of this long arc, everything quiets down again. Before you drift off, let's gather the pieces softly, the way you would gather loose blankets at the end of a long day. The facts remain simple. A narrowband signal appeared exactly where it shouldn't have. It lasted just long enough to be noticed, then vanished forever. And when scientists rewound the path of 3I Atlas, they found it drifting near that same patch of sky. Its orbit is retrograde yet oddly aligned. Its chemistry is reversed from the usual recipe: nickel without iron, CO2 without apology, cyanide blooming in light. The pieces don't line up neatly, but they do line up intriguingly. Then comes the debate. Some say it's just an extreme comet pushed to its limits. Others say there's a chance, maybe a sizable chance, that it's something engineered. The Loeb scale places it at level 4, suspicious but unproven. 40% technology, 60% nature. An argument built not on fear, but on evidence and caution. A conversation carried by people who are willing to look up without assuming they already know the answer. And then, gently woven through all of it, is imagination. The idea of a quiet universe filled with watchers who stay silent in the dark forest. The possibility of a mothership drifting for decades. The thought that a mission could span half a century, with perihelion as Act 2 after a signal sent from 600 astronomical units away. These images aren't conclusions. They're simply ways of wondering, ways to stretch your mind without snapping it. But now, the scale of this story begins to shrink. The universe steps back. Your world steps forward. You are no longer hovering above Mars with 3 orbiters. You are no longer standing at the sun's edge, waiting to see whether a traveler adjusts its path. You are here, in your room, in the soft light that warms your pillow. You can feel the breath moving in your chest. You can feel the blanket settling around you, a quiet weight that anchors you to the moment. And somewhere out there, far beyond the window, beyond the stars you can't see through the night sky glow, 3i Atlas is nothing more than a faint fleck of dust navigating the dark. All of its mysteries shrink to the size of a distant grain. Whatever it is, whatever path it chooses, whatever story it writes next, it writes it slowly. On human timescales, it moves like a feather drifting through water. You are allowed to rest while it drifts. You are not the one tasked with deciding whether it emitted a signal in 1977. You are not responsible for proving or disproving its mission. There are entire teams of astronomers, engineers, and analysts watching the sky, gathering data, checking models, and waiting for its return from behind the sun. And they will still be watching tomorrow. You don't have to join them tonight. Let yourself sink into that simplicity. Not knowing is not a failure. It is an invitation to keep listening, to stay curious, to make peace with mysteries that do not demand immediate answers. We live in a universe where 72 seconds of radio noise can ignite 50 years of debate, and that is its own kind of beauty. A reminder that even in cosmic silence, discovery keeps unfolding at a pace that respects your breathing. You have traveled across billions of miles in your imagination tonight, and now you are returning gently to the small, safe space of your bed. Your heartbeat steadies. Your thoughts soften. The traveler fades into the background. Its path continues whether you watch it or not, and that is the gift. You are not required to hold the universe together. Tomorrow, if something changes in its orbit, you will hear about it. Tomorrow, if new chemistry is detected, it will be shared. Tomorrow, if the object emerges exactly where expected, astronomers will confirm it. Tomorrow, the story will continue without you having to solve anything. Tonight, the only task left is to rest. The philosopher's reminder still rings true. The honest position is not belief or denial, but simply watching and resting. The universe does not rush you. It does not push answers on you. It gives you questions, and then it gives you the quiet time to think about them or to sleep through them. And so, if 3i Atlas truly emitted a signal in 1977, the universe has already been whispering to us for nearly half a century. Tonight, you can let it whisper without you. You are safe. The universe is quiet enough for you to sleep.